Welcome to the Walton Pi. Today we're going to go through this problem from Abstract Algebra about R modules. Okay, so let's let I be the ideal generated by 2 and x in the ring R equals the integers adjoining x, so the polynomials over the integers. Show that the non-zero element 2 tensor x minus x tensor 2 in I tensored with I over R is a torsion element. So, in order to do that, we just need to show that it is annihilated by some non-zero element. And it's actually giving us a hint as to which elements to pick. So we are going to show that 2 tensor x minus x is annihilated by both 2 and x. So that's going to be the first thing we're going to do. And then the second thing is we are going to show that the submodule of I tensored with I over R generated by 2 tensor x minus x tensor 2 is isomorphic to R mod I. So, to get started, let's look at what is 2 times 2 tensor x minus x tensor 2. Well, we can distribute this through. So this is 2 times 2 tensor x minus 2 times x tensor 2. And now we're going to go through and show what these are equal to. Well, we can move this 2 onto the x term. We're going to move this 2 onto this x term here. So this is equal to 2 tensor 2x minus 2x tensor 2. Okay? Just from that, it doesn't look like we really did very much because they're still looking very similar. But the thing is, this is a tensor product over R equals the integers adjoin x, meaning x is something that we can move around. So this is then equal to 2 tensored with 2x minus x times 2 tensor 2. So this is 2 tensor 2x minus, and now this x can move. So that's going to be equal to 2 tensor 2x, which goes to 0. So there we go. We have first successfully shown that this is annihilated by 2, and second, that 2 tensor x minus x tensor 2 is a torsion element. So now let's look at x. So for a second one, what we want to do is we want to stick the x on this. So we got x, 2 tensor x. One sec, let me just write this down and we'll get there. X tensor 2. Okay, so we are going to want to put the x with this 2 and this x with this 2. So we're going to stick the x's on the 2's in both cases. So what we get is that we get a 2x tensor x minus x tensor 2x. Now remember, this 2, that is also in z adjoin x. So that means what we can do is we can then say that this is equal to x tensor 2x minus x tensor 2x, which goes to 0. So there we go. That's how we're going to go through this, and this has successfully shown that it is annihilated by both 2 and x and is a torsion element. Now what we have to do is we have to show that the submodule of I tensored with I over R generated by that element is isomorphic to R mod I. Well, let's first look at what is R mod I. So we have R mod I. This is equal to z adjoin x modded out by the ideal generated by 2 and x. This is just the cyclic group of order 2. Because there's only 2 different things we can have. We have the constant of 1, or we have the constant of 0. Those are the only 2 elements that we have. So we are going to just need to show that the ideal generated by 2 tensor x minus x tensor 2, there's only 2 elements in that. And in fact, that's pretty straightforward to do. Let's look at 2 tensor x minus x tensor 2. And the way that we're going to be getting new elements is we're going to just be adding this onto itself, because the only operation that we care about are groups, because this is just a group. It's not going to be a ring. That's all we're dealing with right now. So we have this plus itself. Well, this is just 2 of those, which we already showed goes to 0. So that means that the size of the ideal generated by two and then x tensor 2, that is 2 as a group under addition, and so there we go. That is enough to show this is the case. I hope this video was helpful. If it was, please consider subscribing. I hope you have a great rest of your day, and good luck with all of your math.